9.3 is all about chemical hazards. Notice up in the box right there, it talks about how chemicals are all around us, and they can all be harmful in large enough doses. You see that quote there: "The dose makes the poison." Many things we can handle on low concentrations, but if we have a bunch of it, it's bad. So there are many examples. Even water, you can drown, right? You can drink too much water, depending on how toxic something is, how risky something is. The dose could make the poison. Any chemical can be harmful in large enough amounts, no matter what it is. If you have too much of it, it's a bad thing. There's kind of a definition of pollutant there. Make sure you're good with that. I think you probably are. Chemical hazards are not necessarily pollutants, and pollutants are not necessarily chemical hazards, but there's certainly some overlap. So let's look at the different types of chemical hazards. Carcinogens you've probably heard of. Those are things that cause cancer. So things like some of the chemicals that are in cigarette smoke and many other things. Chemical mutagens are going to be things that cause genetic mutations, so they're going to affect our DNA. Teratogens are things that harm embryos and fetuses. Neurotoxins are things that are going to affect the nervous system. Neuro always means nervous. Remember that our brain is part of our nervous system, so anything that is a neurotoxin is going to affect our brain. Endocrine disruptors are chemicals that interfere with the endocrine system. We're going to look at BPA as a specific example of an endocrine disruptor, but that's going to mess with a lot of your body systems and could be potentially really dangerous. And then allergens you're probably familiar with because you probably have allergies of some sort. And those are chemicals that overactivate the immune system. The picture on the screen, dust mites, that's an example from nature. Something that a lot of people don't think about is the indoor chemical hazards that we face. So you're seeing a lot of those on the screen here. I think many of us are comfortable with gasoline as an indoor chemical hazard. When you pull your, maybe you've dumped gas into your lawnmower in the summertime and your whole garage smells like gas. Well, of course, if you have enough of that, that can knock you out and potentially kill you. So office equipment puts out VOCs, which are volatile organic compounds. Things like lead in paint. Fireplaces, of course, can release particulates. Insulation can be poisonous. Things like formaldehyde can be in some furniture and carpets. We use chloroform to treat water. Sometimes that's kind of an outdated thing, but does still show up from time to time. If we have space heaters and things like that, they can release carbon monoxide, and that can be really bad. Asbestos can be really bad. So let's move on to outdoor. Outdoor hazards would be things like things that come from volcanic eruptions or human sources, things that we pump into the air. Pesticides and fertilizer runoff and things like that tend to overlap in the ground and in the water. I think we're probably good with that. We've talked most of the year on that stuff. This, I just want to talk about briefly, bioaccumulation and biomagnification. We learned this with invasive species. You should know this really well at this point. If you don't really thoroughly understand this, read the crap out of section 9.3. Look back at that invasive species stuff we talked about with the Lake Erie watershed. I'll post a video to Canvas to kind of jog your memory a little bit. But essentially the idea is that contaminants get passed up the food chain. Producers suck in these poisons. Something eats it, something eats it, something eats it, something eats it. And we're at the top of the food chain, and these toxic substances become more and more toxic as we head up the food chain. That's 9.3.